quite well could happen is I'm gonna look at that and go, how? What did they do? All right, I'm not seeing any work, I'm just gonna mark it wrong. And then about halfway through, I'm gonna go, oh, wait a second, oh, it was the calculator thing.
That's crazy,
So-
it took you that long.
Yeah, it does sometimes. I'm slow. So, one, show your work so I know, okay, she did everything right, okay. This is she mistyped something or something else is going on. I'm more apt to catch it if I'm seeing the work. But if I just see an answer, then,
Yeah.
you know.
So if our calculator does the long one, should we put like a little note, be like, hey, my calculator has all the zeros in it?
You shouldn't have to, so what, if you don't do that and I hand it back and it's marked wrong, you go, wait a second, and then you come up to me and you say, it's my calculator's fault.
Okay.
Now, hopefully, I'll be attuned, and when we have the quiz and I'm grading it, I'm gonna go, oh, okay, yeah, I know what's going on here, but, you know, I'm in my late fifties, it happens. All right, let's do another one of these, a little bit more complex calculation. It's still a plug and chug, but another place where people mess up. Let's do the gravitational force between the Earth and the Sun. All right, so the gravitational force, Earth. So 6.67 times 10 to the negative 11th, because, well, that's that, times the mass of the Earth, 5.98, times 10 to the 24th, times mass of the Sun, 1.99, times 10 to the 30th, divided by the distance between them, and at this point, I can't remember.
How do you know all of those numbers?
Because I was using these numbers a couple days ago in a different class.
Oh, okay.
Average radius Earth, 1.5 times 10 to the 11th. Okay. So 1.5 times 10 to the 11th squared.
So is that 1.99?
Yes, 1.99 times 10 to the 30th.
Okay.
Close I can get the approximation here. Do you have an answer?
I got 5.291 E66.
I think I can safely say it's not that, it's definitely not that hard. And I'm gonna guess I know what you did wrong. Oh, that number, that 33 is wrong. Two. You got somewhere around there? What'd you get, Tony?
3.527 times 10.
Units?
What did she say, 3.5?
Yep.
That's what I got too.
Oh my
Okay.
goodness, guys, I got that, oh, sorry.
I actually didn't get that.
Weird.
All right, were you off on the exponent of the 10 or on the main number?
Both.
Both?
Maybe it's because I put the whole numerator in at once and I didn't do it one at a time.
Ideally, it should not matter, but I'm not sure. The biggest mistake I see, and I think what Brianna did the first time, did you get this answer at this point?
I haven't yet, no, that's okay.
The most common mistake that I see on this is when people type it into their calculator, they do 6.67, EE negative 11. One of these markers, there we go. 5.98, EE 24 times, I guess you need a multiplication symbol there. 1.99 times 10 to the 30th, divided by 1.5 EE 11 squared.
Oh, we forgot the, you mean?
Actually, no, sorry, 1.5 times 10 to the 11th squared, something like that. If you type it in this way, and I don't know if you did this for sure, but if you type it in this way, it's going to divide by 1.5, and then it's going to multiply by 10 to the 11th squared, which is 10 to the 22nd. You need parentheses around that. That's the most common mistake I see.
Wait, so how come I got 22 for the exponent, 24 for the exponent?
When you typed it in, did you type in 6.67 times 10 EE negative 11?
I was going through a lot, I don't know,
Okay.
most likely.
If you're off by a couple factors of 10, this tends to be where I would expect to see it, because this is multiplying by 10 and then doing 10 to the negative 11th. So that, you multiply by an extra
I don't
10,
know,
10, and 10, and
I
then.
don't even think I hit the negative sign, I don't know. I
Oh,
don't know.
well, that would do it. Definitely mess it up too.
Okay. But the other numbers is fine, I just got 24 instead of 22.
Okay. So that just, it sounds like it's just a simple calculator error.
I got it right this time.
Okay, excellent. So, please, make sure you show your work. I'm gonna do one other calculator bit here. Suppose your calculator doesn't do it, doesn't handle exponents particularly well, or you're unsure. There's another way of dealing with this. Is you do the exponent part and the main part separate. So you do 6.67 times 5.98 times 1.99 divided by 1.5 squared. That, I believe, will get you 35.27. Obviously, we have to deal with the exponents. Exponents, you got 10 to the negative 11th, 10 to the 24th, 10 to the 30th, over 10 to the 11th squared. If you're squaring exponents, it's basically 10 to the 11th times 10 to the 11th, which is 10 to the 22nd. And now, exponents that are multiplied together, you just add exponents, and then you subtract whatever on the bottom. So it's negative 11 plus 24 plus 30 minus 22, and that gets you 21. And so the final answer would be 35.27 times 10 to the 21st. If I move the decimal point over 1 that way, then I have to increase this number here. So this would become, well, in essence, that.
I just knew you were trying to get tricky on me that time.
No, it is just another way, if you know how to use your calculator, which is preferred, and just type it in correctly, that's the preferred method, but this is even potentially, just double check your answer. This is how I knew that 10 to the 66 was not gonna work, because I did basically a crude version of this.
Okay.
But if you had said 10 to the 24th, I would have gone, okay, that's ballpark.
10 to the 24th, that's kind of like.
That was the number that you had said. If you had come out with that before I was told this, then
Okay,
I would not have been able to probably differentiate. I would have gone, okay, I guess I made a little error somewhere.
okay.
But it definitely, I knew it was somewhere in the low 20s. I knew 66 was not right.
Cool.
All right, that seems like a really huge number there. What is the acceleration of the Earth? Or the centripetal acceleration of the Earth?
Would it be the negative of that?
No.
No.
That's the centripetal force. But what is force equal to? In unison would be really cool right now.
Force is equal to acceleration?
Is mass times acceleration.
Mass.
There we go. Don't forget the mass.
Okay.
And so I have 3.527 times 10 to the 22nd equals mass of the earth, 5.98 times 10 to the 24th. Times acceleration. And so it's just a matter of divide both sides by this monster of a number. And you get six times 10 to the negative 3 ish.
Let's say 598. I may not have that in right. That's what it is right there.
I did some crude estimating.
So I am dividing the 5.98 times 10 to the 11th power,
Have a good one.
dividing that by 3 point,
Oh, you're dividing this by that. It's
Oh.
3.527 times 10 to the 22nd, divided by 5.98 times 10 to the 24th.
oh, I did it right there.
Got a number, but I don't know if it's right.
What'd you get?
0.0058.
Okay,
Wait, sir, so that says 24 over there?
yes, that's 24.
Oh.
Yeah.
Oh, no. Well, that's fine.
So that was my crude estimate. So units?
Give it to a girl.
Meters per second squared.
What?
Say it again, Rebecca?
Meters per second squared, cause
Yeah.
it's acceleration.
Yep. We're not done yet. We can do at least one more thing. Good news, we can do at least one more thing. Questions before we do the one more thing?
Oh, I have a question.
Yes, I think it didn't involve that stuff.
Are we going to get this formula on a test when
Oh.
we're asked to do this?
Yeah,
Okay.
you'll have the
just
formula and the
making
value,
sure.
you'll put G. All right. So what is the force due to gravity acting on me?
9.8.
That's the acceleration due to gravity.
Oh.
What is the force acting on me?
100 kilograms, 1,000 kilograms. Can't wait.
There's a big difference in those two numbers.
1,000, she had it right, 1,000.
100.
Thank you, 100 kilograms.
Yeah.
Oh, I thought you were gonna keep going, that's my mass, that's not that's not the force due to gravity.
Oh.
It's a 3.5573 times 10 to the negative 9 on you.
On me. From, force due to gravity, sorry, force due to gravity from the earth,
Oh.
not the book. Force due to gravity on me from because of the earth. There are two ways of finding it, there's the classic way. What is the general word that we use for the force due to gravity acting on me?
So it's mass times, gravitational force, 9.8.
What is 9.8 meters per second squared?
The gravitational pull to the earth.
It's not gravitational pull. Weight is the gravitational pull.
Okay.
What is 9.8 meters per second squared?
Acceleration.
Thank you. Did you hear him?
No,
Say it again?
It's the acceleration due to gravity.
I actually did think that, but thought it was wrong, so.
So why did it sound like the question you asked us was tricky? What did you ask us?
I said, what's the force due to gravity acting on me? One, I forgot to say from the earth, so that was my fault. But force due to gravity, weight is a special case of force due to gravity. So here, right now, the force due to gravity between me and the earth is my weight, or I could just make it sound fancy and call it force due to gravity. Or gravitational force.
Okay.
And so my weight is 980 newtons. However, we have a second formula. Let's use the second formula. And we better get an answer somewhere around there.
I automatically thought that that's what you were talking about.
I would have accepted if we'd gone that route first.
That's what so I started doing that, because I thought that's what you wanted.
Did you come up with an answer?
Hold on.
So how close are you to the center of the earth?
I am 6.38 times 10 to the 6th meters away.
So I'm not sure, but I think I got 3.98 and the 16 to the 6.
I'm gonna say that can't be right, because I should be getting somewhere around 980.
Okay, I told you.
Wait, how do you know how far away you are from the center?
The average radius of the Earth is about just under 6.4 million meters. That's the average radius.
Okay.
And so that's just a number that is stuck in my head. Sometimes I see 6.37, sometimes I see 6.4. Now, Winston-Salem specifically, because the Earth is not a perfect sphere, it's squashed at the poles, and so it sort of bulges out in the middle. Good enough for what I'm doing here.
And we're in the
979.
second floor of the building.
So what was that?
I'm just joking.
Okay, Brianna,
Yeah, that was not.
979.
900,
79.90880
I got that as well.
Yeah.
Newtons.
you just didn't want to come up to be the same, did you?
Oh, wait a minute, so, okay.
So why would we do this other way over just finding?
Because,
Mr. Wait, oh, go ahead, sorry. Okay.
hopefully you can accept that those are close enough to the same answer,
Nope.
Yes.
What?
except for Latoya. So, my mass, so a massive object, times G is equal to big G, mass of the planet, times mass of the object over r squared. Mass of the object cancels out. I now have a formula to find the acceleration due to gravity, depending upon where I am. If I know the mass of the planet, I know the distance from the center, I got a formula to plug into. One of the questions on the homework deals with what is the acceleration due to gravity at, I think it's 100 kilometers. I forget whatever the official edge of space is. They arbitrarily picked a number. I think it's 100 kilometers is the distance to the edge of space. That's where officially we say Earth ends. And so one of the questions deals with the acceleration due to gravity of satellites and things like that. And it turns out it's really not that far off. Once you get to the edge of space, the acceleration due to gravity is still more than 8 meters per second squared. Because the radius of the Earth is so huge compared to how far you are away from the surface of the Earth.
So where did you get 6.38 from?
I just happen to know the average radius of the Earth.
Have a good one,
It's
Jesse.
the radius of the Earth. Because that r is the distance from center to center. All right, so next week, something to look forward to, black holes. We talk about how big does the sun need to be in order to become a black hole, how big does the Earth need to be a black hole. The answer might surprise you, or not, I don't know.
Cliffhanger we all needed.
That's right. And then I might reveal who shot JR.
What?
Ask your parents if you don't get the reference.